Hi, my name is Akash, and welcome to my presentation on Lab 1 regarding charged tapes. So the introduction, basically the goal of this lab was to observe the interactions between charged objects, and we did this by charging pieces of Scotch tape and observing the tape's interaction with other objects, both charged objects and neutral objects. So this lab helped us visualize a couple of different physics principles that we've been discussing, and those include calculating the electric force, which is done by multiplying the electric field by the charge of an object. The gravitational force, which we haven't learned in this class, we learned in a previous class, but this is calculated by multiplying the mass of an object by the gravitational acceleration on the planet. So for Earth, that is 9.8 meters per second squared. We also discussed the behavior of charged objects, and this concept basically discusses how charged objects react while placed near other charged objects, and how like charges will repel and opposite charges will attract. We also learned about excess charge, and this concept basically regards what happens to an object when it acquires a net charge and how the excess charge will move to the surface and alter its interactions with other objects. So in summary, in this lab, we're going to visualize how like charges repel each other while opposite charges attract, as well as how electric charge can transfer between objects. So we were basically tasked with carrying out 4 different experiments. The first was we charged 2 pieces of Scotch tape in a similar fashion to acquire the same charge by ripping them off of other pieces of tape. When these 2 tapes were brought near each other, we saw that they repelled, meaning that these 2 tapes had the same charge, same sign of charge. The second experiment involved us charging 1 tape and bringing it near a neutral object. We used a water bottle, and we saw that the tape was attracted to the water bottle, and that is because the excess charge on the tape polarized atoms on the neutral object and created that attraction. The third experiment we were tasked with doing involved charging a pen negatively by rubbing it in our hair, and this tape was attracted to the pen, so therefore the tape we learned was positively charged because it was attracted to the negatively charged pen. So the last experiment was to positively charge 2 pieces of tape the same way, and to float one on top of the other by putting them close enough to where the force of the electric force negated the gravitational force on the top tape. And the tapes repelled because they had like charges. So in GlowScript, we were tasked with modeling this experiment regarding the floating tapes. And so to do this, we needed to determine the electric and gravitational forces. So I found the gravitational force by using F equals mg with the m that I measured myself of the tape and multiplying that by 9.8 meters per second squared, as you can see in the top right. And then with that value, we set it equal to kq over r squared, the electric field calculation. And then in solving for Q, we were able to figure out what the charge of the top tape was. And we also found the R we use in that equation is basically how close the tapes had to be to see the floating of the top tape. So then within GlowScript, I needed to show how these 2 tapes were interacting with each other. So to do this, I created 2 rows of spheres to represent the 2 tapes on top of each other, and I would visualize the forces seen in the free body diagram in the center of this slide. So I first calculated the electric force on both objects and showed those arrows in yellow. And then I calculated the gravitational force, and those shown in red. And the calculations I used to find the lengths of these magnitudes of these forces are the same as in the previous slide. So I created the electric forces in yellow and the gravitational forces in red, and the bottom tape's gravitational force you cannot see because it is the exact same magnitude as the electric force on that tape, so it's completely hidden. So this is the model that was created. So what if electrons had positive charge and protons had negative charge? Honestly, not much would change, as the interaction between like and opposite charges would still be the same, in that opposite charges would attract and like charges would repel. So the new electrons, which are now the positive charges, would still repel each other, would repel other positive charges while attracting the negative charge. So to use these tapes properly, it's important that you don't touch them for too long, because the more time that tapes spend touching a neutral object, these charged tapes, the less net charge they'll have, because the net charge will leave the tape through conduction. As you can see in this diagram here, the charge from the charged sphere, when touching this neutral object, is disseminating onto the neutral object through that concept of conduction. So this has been my report on Lab 1. Thank you for watching, and yes, thanks.